Hello students, in this video I am going to explain one of the important chapter of science for grade 8, the light reflection. Okay, so please watch the videos till the end. I'll explain each and every concepts. Okay, first concepts, what makes things visible? Light helps us to see an object, children. So no, we can't see objects in the dark. Okay. See, what is light? Light is a form of energy which enables us to see an object. That is the basic definition of light. Okay. So you can see this apple. Okay. Only when the light falls on this apple and after reflection, it reaches to your eyes. Okay. That is the main concept. We are able to see any objects when, okay, light gets reflected and reaches to our eye. So an object becomes visible when the light emitted or reflected by it reaches our eyes. Next concept. What is reflection of light? See, reflection of light is nothing but a bouncing back of light ray when it falls from a solid surface. You see, this torch, light is falling on this surface, it is bouncing back. This phenomenon of bouncing back of light ray after striking a solid surface is called as reflection of light. Okay, so when light falls on polished or shiny surface, it changes its direction. This is called reflection of light. Okay, it is a phenomenon of bouncing back of light after striking a smooth polished surface. Get clear? Next one. Okay, see children, this is a mirror. Okay, this light is striking. The light ray which strikes is called as incident ray. This is bouncing back. Okay, this is called as reflected ray. Okay, okay. If you draw a 90-degree line on this plane, this is called as normal. The angle made by incident ray and the normal is called as angle of incidence I, whereas angle made by reflected ray and the normal is called as R, that is angle of reflection. So some terms are there, you should know. They may ask in the exam for 2 marks. Incident ray, the ray of light falling on the surface. I'll make it zoom for you children. Yeah. What is incident ray? The ray of light falling on the surface. Reflected ray, the incident ray bouncing back in the same medium after striking the reflecting surface. Next, point of incidence, the point of the mirror surface where the incident ray strikes and reflected ray bounces back. This point P is point of incidence. Normal, okay, normal ray. So if the line drawn perpendicular to the reflecting surface at the point of incidence, this one, normal. Okay, it's not a ray, it's just a normal perpendicular drawn at the point of incidence. Angle of incidence, angle between the incident ray and the normal, represented as angle I. Angle of reflection, angle between the normal and the reflected ray, angle R. Okay, so these terms you should know. Next, children, and same thing you can see. This is the mirror, incident ray, reflected ray. This is the normal. Okay, this is angle of incidence, angle made by incident ray and the normal, angle of reflection. Okay, angle made by reflected ray and the normal. Yes or no? They're asking in the exam laws of reflection, children. Laws of reflection. So there are 2 laws you should know. Okay, first is what are the angle of incidence. Okay, first law, laws of reflection. The angle of incidence is equal to the angle of reflection. Okay, this angle I is equal to angle R. And second one, the incident ray, the reflected ray, and the normal. Okay, at the point of incidence, all lie in the same plane, on the same plane actually. Okay, this is the 2 laws you should know, children. Next concept. Okay, they are asking in the exam, discuss briefly the characteristics of image formed by the plane mirror. Okay, so image is always formed behind the mirror. First thing, this is the mirror, this is the object. And one girl is there, image is formed behind the mirror. Next, it is virtual image, which means it cannot be opened in the screen. Okay, image formed by the plane mirror is always virtual and erect. Image is upright and laterally inverted. Okay, and image size and distance are equal to object size and distance. It means, okay, if the object is suppose 3 feet in front of mirror, so image is also 3 feet behind the mirror. So we can say distance of image behind the mirror is equal to distance of object in front of it. And suppose if the height of this object is 5 feet, so image height is also 5 feet. So we can say image is of same shape and size as that of the object. It is laterally inverted in the sense means children. Okay, if object raises a left hand, the image will raise a right hand. Yes or no? Here definition is there. What is mirror? Mirror is a surface that reflects the light. So we have two types of mirror: spherical mirror and plane mirror. Plane mirror, a straight, highly polished, smooth reflecting surface is called as plane mirror. Is it clear? Next, lateral inversion syndrome. Okay. The phenomenon due to which the left side of an object appears to be right side of the object in its image in a reflecting medium and vice versa is called as what? Lateral inversion. You can see when you go to that parlor. Okay, so the if you raise the right hand, okay, image will raise the left hand. Okay, yes or no? Here, that is that one of the white paper if you see. Okay, and it is emblazoned written. If you show in the plate mirror, the image will be like this. Okay, next. Multiple images due to the plane mirror. See children, when you take two plane mirror and place them at some angle theta, okay, so n number of images are formed. There are some rules that you should know. The number of images formed depend upon the angle between the two mirrors. If the two mirrors make an angle theta between them and the object is placed in between the two mirror, the number of images formed is given by n is equal to 360 by theta minus 1. Okay, what is the condition? When the two mirrors are kept parallel to each other. Okay, theta is how much? 0 degree. The number of images of an object is what? 360 by 0. This is not defined right now. So infinite image is formed. Next, when the two mirrors are kept perpendicular to each other, means when theta is 90 degree, so 360 by 90, 4 minus 1, how much? 3 images is formed. When the two mirrors are kept at an angle 60 degree, so 360 by 60 minus 1, so 6, 6, 36, so 6 minus 1, 5. Okay, so like this we can, so here you can see angle between the mirrors is there, number of images formed. Whenever it is 45, 7 images, 60 degree, 5 images, 90 degree, 3 images, 120, 3 images, 2 images, 180, 1 images. Okay, when 0 degree, infinite number of images. So two plane mirrors are inclined at these angles, then number of images you can see. Okay, children. Next, we are going to same concept it is repeating. Okay, so we will see. Next is types of reflection. Okay, see children, there are two types of reflection: regular reflection and irregular reflection. A regular reflection takes place from the smooth surface. Okay, so if a parallel incident rays, okay, are reflected in such a way that all the reflected rays are also parallel to each other. So you can see these are the parallel rays which is incidenting on this mirror, a smooth and a plane mirror. So light rays are also reflected in the same direction, parallel direction. So this is regular reflection. It takes place through the smooth surface. It occurs only if the light rays are falling on a highly smooth and polished surface like plane mirror. Okay. Similarly, irregular reflection, okay, it will take place through the rough surface, children. You can see here, this is a rough surface. When a parallel beam of light ray falls on a rough surface, reflected lights are not parallel. So if the parallel rays falls on an irregular surface, like an uneven surface, then the reflected rays scatter in all the direction. You can see. Okay, so this is called as irregular reflection. It occurs if the light rays are falling on a rough surface. This type of reflection enables us to see the objects around us. Next, kaleidoscope is a device which is used to see the multiple images of the object. It has three inclined mirrors at an angle 60 degree. You can see. Okay, here, here, and here, this side at 60 degree. Arrangement is usually kept in the cylindrical box and has a few pieces of colored glasses kept at one end. We can see beautiful patterns and designs due to the multiple images formed by the mirror. You can see. Okay. Next, we have last concept children, human eye. Okay, being a good student, you should know about the human eye. It is there in the 10th standard also, children. Okay, you can see this is the diagram of eye. This is the eye lens, which is convex lens. This is the iris. Okay, this is the cornea. This part is cornea. Okay, this is the ciliary muscles which hold the eye lens. This is the retina where image is formed, and this is the optic nerves. So cornea, what is cornea? Human eye is like a cornea. Human eye is like a cornea. Light enters the eye through the transparent membrane that is called as cornea only. Okay, this part is cornea, children, you see. Iris. Behind the cornea is the muscular diaphragm, which has an opening. That is called as what? Iris. This is the iris. Pupil. The pupil is the opening in the center of the eye. This gap is there. Okay. Hole is there through which light enter into the eye lens. That is called as pupil. Ciliary muscles helps to change the curvature of the lens and change the focal length. Okay. This is the ciliary muscles actually. Retina. The lens system forms an image of an light on a light sensitive screen. That is called as what? A retina. You see, this is the diagram. Better you can draw this diagram. Next, power. Some terms are there, children. You should know related to eye. Power of accommodation of eye. The ability of eye lens. The ability of eye lens to see both near and distant objects by adjusting its focal length is called as power of accommodation of eye. Okay, so our eye can see the object which is near also, the object which is far also. This ability of eye lens to adjust its focal length is called as what? A power of accommodation. What is near point? Minimum distance at which the eye can see objects clearly is called as near point or least distance of distinct vision. For a normal eye, it is 25 centimeter from the eye. Far point, the farthest distance up to which the eye can see objects clearly. For a human eye, it is infinity. Okay, so you should know near point how much? 25 centimeter, far point infinite. Okay, infinity we can say. See, children, there are some defects in human eye: myopia and hypermetropia. Myopia is also called as short-sightedness. Hypermetropia is also called as long-sightedness. What happens, children? A person suffering from myopia cannot see the distant objects clearly. Okay, he can see the nearby objects clearly. What happens? Image is formed in front of retina. Actually, image should form at retina, right? When light is coming from distant objects, it is meeting in front of retina. So, distant objects appear blurred for the myopic eye. So, we can correct this defect by using concave lens, diverging lens. So, light will get first diverge, then it will meet exactly at the retina. Hypermetropia, what happens, children? Here, the person can see the distant objects clearly, but nearby objects appear blurred to him. So, light ray which will come from the nearby objects, it is meeting behind the retina. So, to rectify this defect, we are using convex lens, converging lens. So light ray will first converge, then again it will converge at the retina. You can see here myopia, defect of vision in which a person can see nearby objects clearly, but cannot see the distant objects clearly. Causes: increases in the curvature of eyeball, increases in the length of eyeball, or we can say decrease in the focal length. Next, hypermetropia. Spelling here wrong is there, children. You can rectify hypermetropia. Defects of vision in which person can see distant objects clearly but cannot see nearby objects clearly. Causes: decrease in the curvature of eyeball and the focal length becomes more, children. Okay, I'm just writing here. Here you can see, children, myopia spelling MOYO, myopia. Okay, is also called as what? A short-sightedness. Short-sightedness. And second one, what we learned? Hypermetropia. Hypermetropia spelling is HY. Yeah, hypermetropia. What is what? A long-sightedness. Hypermetropia. Long. Is it clear? I hope you understood this concept, children. Okay. So care of eye. Eyes are very important organ and they are sensitive too. So proper care of eye is very important. Some tips for care of your eyes are as follows. Do not read in too bright or too dim light. First thing. Okay. Next, do not look directly at the bright objects or at the sun. Next, do not keep the object on a book too close to too close or too far to your eyes while reading. Next, if something gets into the eye, do not rub the eye. Wash it with cold water. Next, if there is any problem of the eye, have a checkup and use suitable spectacles if advised. Last, deficiency of vitamin A causes night blindness, so take food rich in vitamin A. Okay, so these are the ways how you can take care of your eyes. Visually challenged persons. See, children, some people face with disability of vision. This disability can be partial or complete. Such persons are called visually challenged person. So for a visually challenged person, life can be very difficult. These people usually show a marked development of other senses like the sense of hearing and sense of touch. They can be divided into two categories, optical and non-optical aids. Okay, so what happens children? Louis Braille was born in 1809 in France. Actually, he became the blind during early childhood because of an accident. He developed the Braille script in 1824. Okay, so what is Braille script? The Braille scripts are written in the form of a raised dots. This system is composed of 63 characters. Each character is written on the grid of 9 cells. This can be written with the help of Braille slate and a stylus. Uh, Reader needs to touch the Braille script to read it. Okay, so through this script, the blind persons can also uh, read. Okay, so this is very, very important. You should know. Okay, rods and cones in the retina. See, the retina contains two types of photoreceptors, rods and cones. The cones are red, green, and blue. The rods work at a very low level of light. The human eye has over 100 million rod cells, children, and cones require a lot more light, and they are used to see the color. So cones are sensitive to color, whereas rods are sensitive to light, intensity of light. Okay, millions of rods and cones are there at the retina, children. Is it clear? Okay, that's all about this chapter later. I hope you understood these concepts. Please share with your friends and subscribe the channel. Thank you.